Hello all. In this session, we are going to cover the linear programming formulation. So, what is linear programming? Linear programming is a technique which helps us to find the optimum solution for a given problem. Now the question arises, what is optimum solution? So basically, it is to find out or to give the best possible outcome for a given problem. Right? Before we discuss how linear programming techniques help in solving various mathematical problems, now let's understand what kind of problems can be solved using this technique. Now, the many industries and companies are using this technique to solve their daily life problems. So let's focus the structure and the formulation of linear programming problem. The first thing we need to understand is the given problem by thoroughly going through the statement. And then in the next step, we have to identify the basic elements to convert it into linear programming problem. The process of these two steps is known as formulation of linear programming problem. So now from this concept, we come to know that there are two aspects of linear programming problem. First one is to formulate the LPP, that is linear programming problem, and second is to find the solution for the same. Now let's begin the formulation of linear programming problem with the help of an example. So in this question, we'll see that there is a statement that a firm manufactures two types of product and products are A and B. So what we will do, we will write here that there are two types of product A and B. Okay. And the firm want to sell at a profit of 12 and 13, right? On type A and type B. So means profit of A product is 12 and of B product it is 13. And each product is processed on two machines. Machines we have two, that is G and H. So type A requires 1 minute of processing on G and 2 minutes on H, while type B requires 1 minute on G and 2 minutes on H. The machine G is available for not more than 6 while H is available for 10 minutes during any working day. Formulate the problem as linear programming problem. Now see, first thing what we have to see while formulating any linear programming problem, that whether it is a case of cost or profit, because every firm want to minimize the cost and they want to maximize the profit, right? So here the profits are given. So it means that the problem is related to maximization. If it is given cost in the question, then we can say that problem is related to minimization. But right now we have a profit of 12 and 13. So we say that this is a case of maximization, right? Now in order to simplify this statement, we will make a table. Now, first of all, we will see that the profit is given for what? It is given for type A and type B products, right? So, we will take products as A and B. We will make a table. And next thing is another thing apart from product, it is given machines. Okay. So, two types of machines are given. So we write product in column form and machine in row form so that we may able to formulate a matrix of 2 by 2 in this way. Okay, now you can see here that each product, this line, each product is processed on two machines and type A require 1 minute on G. So type A requires 1 minute on G. I will write here A requires 1 minute on G. Okay. And 2 minutes on H. So this data is for product A. So 2 minutes on H. Fine. In the same way, type B requires 1 minute on G. So B here and G here. 1 minute on G and 1 minute on H. So 1 here. So this is 1 and here I will get 1. Clear? And next thing is profits are given. Profits are given for product A and B. So I will write here profit. Profit is 12 for type A and 13 for type B. And the last step is that the machine G is available for not more than 6 minutes. Means that we can use machine G for 6 minutes only. We can't use the machine for more than this. So this is the maximum limit. We can use the machine for 5 minutes, 4 minutes or 6 minutes, but we cannot use it beyond 6 minutes. In the same way, machine H is available for 10 minutes. So here I will write 10. Again, this is the maximum time available for this machine. Clear? So now while formulating the linear programming problem, first of all, we will make the equation which either includes cost or profit. So here the profits are given. So I will write maximize Z is equals to 12 for A product plus 13 for B product. Okay. Rather taking A and B, we use x1 or x2 or x or y, because when we plot the values in the graph, we always take x-axis and y-axis. So we can also write it as 12x plus 13y by taking product A as x and product B as y. It's one and the same thing. Another thing is, but how we will be able to achieve this objective, this maximization objective, when the constraints are fulfilled. So basically we write here, this profit can be achieved subject to constraints. Now what are the constraints? So the constraints here are that we can use either machine G or H, and G is used for 6 minutes and H is used for 10 minutes. Product A will require 1 minute for processing, which is given in the question that type A requires 1 minute of processing on G. So 1x, and it is given in the question also, here it is 1x and 1y. This is equals to 6, not equals to 6. This should be less than or equals to 6. Means that we can use G machine either for 6 minutes or for less than that, but not more than that. So in the same way, another equation is 2x, that is this one for H machine, plus 1y, that is for this H machine. For you can see here that type B requires 1 minute of processing on H, and maximum time which is used for product for machine H is 10 minutes. So again we can use this machine for 10 minutes maximum. We can use it for less than 10 minutes or equals to 10 minutes. But the condition here is that where x and y, they are greater than and equals to 0, because non-negativity concept is there. They can't be negative. So this is non-negativity. Clear? So this way we will able to formulate the linear programming problem.